Hello everyone, welcome to Learning Academy Foundation from Mr. Andrea. Today I would like to show you about the physics program for lower secondary. First section will be about electricity, where the students will learn the concept of electricity and electric current, how to generate electricity by spinning a magnet in a coil of wire. They will see that objects can become positively charged or negatively charged, so this is called static electricity. And also that when charged objects discharge suddenly, an electrostatic spark is formed. The students will see that electrical current flow easily through a conductor but does not flow through an insulator, and also that circuit diagrams use symbols to show electrical components are connected in a circuit. Still about electricity, the students will see different models like water in a central heating system can help them understand electrical circuits, and that electrical circuits can be connected in series, meaning all the components are in the same loop, and that in circuits connected in parallel, the components are connected on different branches. They will learn how electric circuits work and how to measure current and potential difference. And finally, they will see that the more resistance there is in a circuit, the less current will flow. The next section will be about electromagnetism and magnetism, where the students will discover how invisible magnetic fields can be revealed using iron filings or a compass. They will find out how an electromagnet uses an electrical current to generate a magnetic field. They will see that certain materials feel a magnetic force, so magnetic force can be either attraction or repulsion. And finally, they will learn how to make a magnetic compass. The next section will be about energy, where the students will learn about the different types of energy in the homes and how bills are calculated, the different ways that electricity can be generated from either renewable or non-renewable energy, the different energy stores and how energy transfers between different stores, and also how equations can be used to calculate how much energy is stored. The students will learn about heating and cooling and conduction, radiation and convection, domestic energy, and finally they will see that combustion is another name for burning. So in a combustion reaction, fuels burn and reacts with oxygen to release energy. The next section will be about forces and movement, where the students will learn about the different types of forces and the difference between contact and non-contact forces. They will see that pressure is a measure of how concentrated a force is. So the amount of pressure exerted on an object depends on the force applied in the surface area it is spread over. They will learn about the difference. They will learn about drawing and interpreting force diagrams. So they will find out how to calculate the resultant forces acting on an object, and also about the difference between motion and speed and how to use the speed equation. The students will find out how to use distance time graphs to describe a journey and to calculate speed, and the difference between weight and mass, how to explain why weight changes on different planets and how to apply the weight equation. They will learn how to identify different types of resistive forces and how to investigate the effect of friction, and also about the forces acting on an object in free fall, and to describe how the motion of an object changes during free fall. Still about forces and movement, the students will learn about common energy stores and energy transfers, and how to apply the work equation, about moments and pivots, apply the moment equation, identify common levers and applications of moments, Hooke's law, and about the spring constant of a spring as being the amount of force needed to extend a spring. They will explore how to find the spring constant of a spring. They will find out about the gravitational forces which pull all objects together. And they will learn how forces work, how to show the difference between force and pressure, how to find the weight of a floating object, and finally they will find out how to show pressure exists in liquids. The next section will be about inventions, where the students will be discussing whether robots will ever take over the world, can they think like a scientist, and whether research into time travel should be banned, can they think like a scientist. The next section will be about solids, liquids, and gases, where the students will see the arrangement, movement, and spacing of particles are different in solids, liquids, and gases. That to change the state of a substance, energy must be transferred to or from the substance. That liquids and gases are both fluids. So fluids can flow or be poured because the particles in them are able to move around freely and can change positions. And finally, the density of an object is calculated by dividing the mass by the volume. The next section will be about space, where the students will see that the solar system is made up of the sun and the objects that orbit around it, including planets, asteroids, and comets. So the sun's gravity holds all of these objects together. That the sun is our nearest star, so it is a yellow dwarf star, and it is found at the center of our solar system. The days, years, and months are periods of time which are determined by the movement of Earth around the sun and the movement of Moon around the Earth. The moon phase is the shape of the visible part of the moon, and this changes gradually over the course of a lunar month. And also that scientists and astronomers often use units called light years to talk about enormous distances to distant objects such as stars and galaxies. Still about space, the students will find out from the Royal National Lifeboat Institution about how tides work and how to make their own scale model of the sun and the earth, and how to measure the strength of the sun with a toilet roll. And finally, they will be discussing whether a human will ever be born on Mars. Can they think like a scientist? So the next session will be about think like a scientist, where the students will find out about the two great scientists, Faraday and Dalton. Next section will be about waves, where the students will see that all waves transfer energy from one place to another. So examples of waves are all around us and include light, sound, ocean waves, radio waves, and radiation. That there are 7 types of electromagnetic waves, which make up the electromagnetic spectrum. Different types of electromagnetic waves have different uses and dangers. They will learn about how light is transmitted through different materials and how to create ray diagrams to show light transmission. And also about the law of reflection, how to draw a ray diagram and the difference between diffuse and specular reflection. The students will learn how light is refracted when it enters a material like water or glass, and how ray diagrams can be used to show the path light takes when it is refracted. and about the features of the human eye and how eyes and cameras both use lenses to focus light and form image. They will investigate the motion of waves in water, what happens when waves are reflected, and the different types of wave superposition. And also they will see that white light is made up of many different colors, each with a different frequency. So it can be split up to produce a spectrum containing all the different colors of visible light. Still about waves, a photographer explains how he uses his knowledge of light and color in his profession. The students will learn how filters affect the light that can shine through them, and how light is absorbed or reflected by different colors of surfaces. They will identify the features of a sound wave and learn about the pitch, frequency, amplitude, and loudness. And also they will learn about the speed of sound in air and the other states of matter, how an echo is made, and how we can calculate the speed of sound from echoes. The students will see that we can hear sounds because our ears turn sound vibration from the air into signals that are sent to our brain. And finally, they will learn how to make a speaker from wire, a cap, and a magnet. The last section will be about working scientifically, where the students will see how can they work safely in the lab, what are the various steps needed in order to do so, and how to spot risks, hazards, and understand hazard symbols. They will find out why variables are important in an experiment, including control variables, independent and dependent variables. They will see that an hypothesis is an idea about how something works that can be tested using experiments. So a prediction says what will happen if the hypothesis is correct. They will see that developing a method is an important part of planning and investigation. It is important to evaluate the validity of each step leading up to the conclusion. The students will see that scientific equations and formulae are used to work things out in science. So using standard units means scientists around the world can work together better. They will also use diagrams to show how scientific apparatus is set up and how to draw them in two dimensions. So common practical techniques that use apparatus include filtration, evaporation, and distillation. Still about working scientifically, the students will see that calculating averages from data is usually more accurate than using one result. So using a table ensures that data is recorded in an organized way. The types of data include continuous, discrete, and categoric. So data can be presented in a number of ways, which depends on the type of variables and the uses. The different types of graphs and charts are used to show results, so they need to be drawn and labeled correctly. So scientists use patterns in the data to reach a conclusion. Data conclusion sums up what has been found out during an investigation. So it should be clearly structured and explained using scientific knowledge. And finally, that scientific studies can be biased. It's important to recognize when this is the case. Scientists review each other's conclusions from new research. That's all about the physics program for lower secondary. Thank you for your attention, students and parents. You can find my contacts below in the slides or in the description. See you next. Bye.